Hello, my name is Mr. Wilke, and we're learning statistics. So today we've got a real quick lesson on normal probability plots and assessing normality, and that's it. Should go fairly quickly. So let's talk about assessing normality. So when is it normal? How do we know? Why does it have to be normal? Well, let's think about that. We learned the z-chart, right? The z-chart only works for normal distributions. And that makes sense, doesn't it? If I have something like this, first off, the mean isn't in the middle. The mean is going to be at the balance point, somewhere over here, right? If I'm however many standard deviations away, remember on a normal curve, it only goes about, what, a little over 3 standard deviations both sides. I mean, well, clearly it goes on forever, but you know, 99.7% of the data is within 3 standard deviations of mean. Well, here, if I go over maybe 1.5 standard deviations, I'm at the lower bound. It doesn't make any sense. Okay, so it has to be a normal distribution, which our density curve will look like that. Now, what if we just have data? How are we going to be able to tell? We could do a histogram, but a histogram doesn't always tell us the whole thing. So what we're going to do is do what's called a normal probability plot. Now, a normal probability plot is a scatter plot, which we haven't talked about in here, but you probably learned in your other math courses. If you have no idea what it is, it's basically you're looking at 2 different quantitative variables and plotting them against each other. So a scatter plot of the ordered pair x comma y, where x equals the data point, y equals the expected z-score corresponding to the percentile of that value in a standard normal distribution. Now, if it's actually normal, then the z-score should be right about where it would be. Does that make sense? Okay, like on our skewed graph, it's going to be a little bit different. On this one, it's going to be where it should be. Okay, so what's going to happen is, well, let's look at some examples. Okay. So I've got some data in my list 1. I have the age at inauguration of all 45 presidents so far. Okay, so we don't have 46th president yet. 45th was 70. 44th president was 47 at inauguration, the first inauguration. Okay, so let's look and see what this graph looks like as a histogram. So turn my plot on. Histogram, graph, zoom stat is zoom 9. And it looks like that. It looks like it's a little bit skewed to the right. Not too much. Not quite normal, but close to normal. Okay? Now, let's look at another one. List 2 is the Fibonacci sequence. This one's definitely going to be skewed, right? If I were to graph this, instead of L1, let's do L2. Zoom 9. Definitely skewed, okay? So this is skewed right by a lot. Now, let's look at the normal probability plot. So if I wanted to do a normal probability plot, where it is, it's this last one right here. Okay? So, normal probability plot for L1. Graph. Zoom 9. And it looks like that. Now, let's look at the difference with L2. This is with the Fibonacci numbers. Zoom 9. What do you notice? The first one was pretty close to a straight line. This one is definitely a curve. Okay? And that's how you can assess normality. If the normal probability plot is a straight line, then it's normal. Now, being exactly normal is difficult to do, especially with a small sample, so there may be little things going on. Let's do L1 again, little wiggles in there. So it's a little bit, and remember there was a little bit of a skew at the end. That's showing up there. Now, my L3. What I did here was I took 100 random numbers from a normal distribution with mean 0, standard deviation 1. So let's do a histogram of L3. See what this looks like. L3 graph, zoom 9. That looks pretty close to normal, doesn't it? Now, let's look at the normal probability plot. Now, could I look at this and say this is pretty symmetric, single peaked, close to normal? Yeah. I mean, if you want to draw the histogram and you can assess that's pretty close to normal, the normal probability plot's not going to surprise you that much. I would guess this one will be pretty straight. Let's find out for sure. Graph. Zoom 9. And that's pretty close to a straight line. Still a little bit of a thing there, but as you can see, this one is really close to normal. The Fibonacci's weren't the least bit close. The presidents were fairly close. This looks a little bit closer, but so a normal probability plot will tell you if it's normal, it's a straight line. If it's close to a straight line, it's approximately normal. Okay? Now, Normal probability plots are not necessarily part of the AP exam. However, if it's asking you to show if something's normal, you can sketch a normal probability plot to say, hey look, this distribution is approximately normal, and then you can use your z-chart to find probabilities and all sorts of fun stuff. And that's it. Like I said, short lesson today, not much to learn, except first, if you're going to use your z-chart, you better have a normal distribution, and a good way to check to see is a distribution normal probability plot. All right, that's about it. Thank you guys for coming. Thanks for listening, and thanks to the Stiff Little Fingers for the t-shirt, and I will see you guys soon.